Okay, welcome back. We will carry on with our discussion on the use of silicone wristbands to complement biomonitoring studies. I'm going to introduce Stephanie, who will help moderate this discussion. So Stephanie Jarmuel is the Chief of the Safer Alternative Assessment and Biomonitoring section at OEHA. And she'll be walking through some of the potential questions for the panel and the guest speakers and the audience to consider throughout the discussion period.
Thanks so much, Laura. So for this afternoon's discussion period, we really wanted to delve deeper into the utility of the wristbands that we've been hearing about from Kim and Heather to complement the program's biomonitoring studies, and also some of the issues the program should consider before deciding to add wristbands to any of our future studies. And to help guide this discussion, we've created some informal questions I'll present on, but we welcome your input on these as well as any other issues that the panel or audience would like to raise. So to preface this, the program exploring the possibility of using these wristbands as a potential screening tool to help identify chemicals to consider for biomonitoring. And then to that regard, should the program consider a semi-targeted approach to be used to only identify chemicals with established methods for biomarkers in humans, whether that's urine or blood or other biomatrices, or shall we consider a more non-targeted approach that it seems like it's possible to do both? And then are there certain biomonitoring matrices such as urine versus blood versus serum that are more appropriate to pair with the wristbands? And if yes, which chemical groups should we consider for pairing, considering what is on our designated list? And then are there study designs or populations, such as surveillance studies or certain occupational groups that we should prioritize for including wristbands if we are to move in this direction? And then finally, since many of the metabolites used in our studies have half-lives of hours or days, is it suitable to have participants only wear these wristbands for one day to correlate with the biomarkers? There's more questions to come. And related to the last question, if the wristbands are only worn for one day, then how could we compare our results to other studies where participants generally wear the wristbands for 1 week or more? I know Kim talked a bit about how you don't really want to compare concentrations on wristbands from different time periods. And so how can we make this data useful as a program if we are only wearing the wristbands for one day? And then can we compare chemicals and wristbands from studies done in humid and hot climates, for example, to studies done in opposite climates? I think there's been some research that shows that the different climates can have an impact on the levels in the wristbands as well. And I don't know if Kim or Heather would be able to talk a bit about that. And then we talked also a bit about active air samplers and how they are sensitive to detecting small amounts of chemicals in the air. And this again might be a question for Kim or Heather. Do the chemicals need to be at specific concentrations in the air to be detected in the wristbands? Would it not be as good as detecting small levels in the wristbands? And then wristbands are used as personal passive samplers. If our resources are limited, can wristbands take the place of air monitoring in our air pollution focused biomonitoring studies, or do we still need to consider having both? And one more page. Communicating wristband results to participants. Since the concentrations on the wristbands are not considered biomonitoring results, we are not required to return participants' results. So just thinking what would be of most use to the participants and how we should think about sharing the wristband results. For chemicals, should we only share the ones that were also included in their biomonitoring samples? Or if you have other recommendations on how we can interpret these wristband results and communicate them to participants. And lastly, if we get to some other considerations, such as the cost of analyses, best practices, practices for field deployment, and additional challenges or limitations we may have missed that you want to bring up for discussion. So we might not get to all of these in the next hour, but we would like the panel and audience to consider these questions. And Kim and Heather, I'm glad to see you're both still here. And I welcome Laura to start the discussion.
Is there one of those four kind of major areas that are highest priority?
Start with the first.
Okay, then maybe we can just have those questions up so we can ruminate on them a little bit. Thanks. So please just go ahead and raise your hand if you'd like to comment or question any of these. And I am able to see our two presenters on screen. So if you'd like to say something, please just use the raise hand function on the Zoom.
Oh,
Go ahead, Heather, and then Kim.
I guess I just wanted to ask for a clarification on one of these questions. So the first one says, should a semi-targeted approach be used or use non-targeted? Why does it have to be just those two? I mean, we use fully targeted methods when using wristbands, which I think are best for if you're going to be supporting a biomonitoring study. So I'm just kind of confused about why you're saying semi-targeted versus non-targeted. And ideally, personally, and this is just me because this is what we do, we can do both at the same time, targeted and non-targeted. So I think that provides a wider breadth of information. So I was just wondering why it said semi-targeted there.
sure. So I can give an example. For many of our studies, just thinking about our air pollution studies, for example, we're looking at pHs, VOCs, and metals. And so I think we automatically would want to include any that we already are including in our biomonitoring samples. But in terms of a semi-targeted approach, if we wanted to see if there are other VOCs or pHs we might be missing, or pesticides, for example, but we still want to focus only on biomarkers that we already have established methods for, then I think we'd want to do a semi-targeted approach versus the non-targeted approach. We could expand and look at chemicals that the program should perhaps consider developing methods for or adding to the designated list. And for some background, sorry, Kim and Heather, the program can only include biomarkers for chemicals that are on our designated list in our studies. So that's why this is of particular interest to us.
Okay.
I think,
Thanks.
Tom, I think Kim had her hand up first. Did you still want to say something, Kim?
Oh, yeah, I have the similar question. Why not use targeted methods?
Okay.
So, and that's the beauty of somewhat the wristband is you could tier it. So you could use a targeted method. There's semi-target, like we have a semi-targeted method that has about 1,530 analytes in it. And then you mentioned presence absence. We have a presence absence method that has like 300,000. But it's not non-targeted. They're 300,000 in the sense that it's a sort of semi-targeted method versus truly non-target. There are very different questions, and in case of Heather's lab, she can do both. So, but they're very different questions. So, it's hard to answer. It's hard for me to answer that question. I'm seeing Heather shake her head, so that's a hard one. I don't know. I guess I will say we do see caffeine in wristbands, to go back to an old question. And at about 80% of our wristbands, we see caffeine. So I kind of think that's coming from the skin, not that people spill caffeine on their skin. But then we actually avoided looking for metabolites, like metabolites of pharmaceuticals, because we wanted to encourage people to wear them. And that can actually discourage people if they think you're going to look for like drugs of abuse or something. So we've actually purposely stayed away and do not include those metabolites or analytes in our method because it could discourage participants. Concerning your last question, may the metabolites used in the programs have a half-life of hours or days? Are you presuming that they only have an exposure once during the wear time? Because if they're constantly exposed through the wear time, then yes, I mean, there's how it gets correlated. That's different. And Heather spoke to that. But if it's a constant exposure, or do you think it's just one acute exposure and it has a half-life of hours or days? Either way, there's an answer in which you could still use the wristband. So you can use the wristband on the order of days or longer. But if it's that they're being exposed to it continuously, but that it is clearing, that's kind of a different question. Heather kind of addressed some of that in her work. So.
I think it will depend on the chemical of interest. And I think for a lot of the chemicals that we include in our studies, we're expecting different exposure routes at different parts of the day, which is why the wristband is so interesting because, for a lot of our air sampling, we can only sample, for example, at a participant's home and get the air concentrations there. But the wristband would be able to tell us other exposures that they're experiencing while at work or in their car or doing other activities. So I think we're expecting sort of continuous exposure over the 24 hours, but from different sources. I don't know if that makes sense.
Yes, it
Which is
does.
why we want the wristbands it would be a better indicator of the cumulative exposure from that 24 hours.
Right. So if that's your
Yeah.
question, wristbands are great. It's a great tool.
Yeah.
Go ahead, Tom.
Well, I want to take a sort of a broader approach to this instead of the specific questions, but the broad question is how can silicone wristbands play a role in biomonitoring? And I think we have to, pose the philosophy I think we've had since the beginning, which is for the designated chemicals, what we're trying to do is the best job of understanding through biomonitoring and other tools to enhance biomonitoring, what's going into the California population, what's in the population and what's going in. And we even like to go beyond that and say, where is it coming from? So with that in mind, I think we have to look at tools like this that come along and say, can it help us with this process of saying, okay, now we have biomonitoring data. Is there something that would help us make it more reliable, make it more understandable? Because our goal isn't just to go out and take the designated chemicals and make measurements of urine and blood. It's ultimately to gain more understanding and protect the health of the California population by understanding how to use biomonitoring. So I think we have to frame this, and I think the answer is yes, we've seen examples, and I think that has to be kind of a project to explore where is it that silicone wristbands can really enhance or fill in some gaps or help us understand the sources of exposure better. When we have, like even today, we learned there are things where we don't understand why there's differences. Why is this population higher? And we're speculating. So we need these kinds of tools when they come along, and if they're demonstrated as their reliability and their feasibility increases, I think we have to make sure they're in our tool set too, to do the best job we can in biomonitoring. Anyway, sorry. A little philosophical, but I think that's kind of the approach to answering that question.
Is that Heather with her hand raised? Okay,
Oh, yeah.
please go ahead.
Well, I guess I just wanted to provide some feedback on the question about wearing one day versus others. I think ultimately it always comes down to the specific question you're trying to ask and answer. I personally don't recommend one day. I would recommend, 5 or 7 days if it's logistically feasible. And would just direct you to the paper Salmon et al. 2024, because that's the study where we started off with 5 wristbands and then took one off successively every day. And in that paper, we report on the number of chemicals we detect based on the number of days it was worn. And the longer they wear it, the more sensitive it becomes to chemicals that are found at lower concentrations in the air. So, I mean, what you measure on the wristband's a function, if it's for inhalation, right? The concentration gradient between the air and the wristband and the physical chemical properties. So chemicals that are at low concentrations, you're going to have a harder time seeing them unless you wear it for longer periods of time. And this is exactly what we see for volatile PFAS. So for research studies that we want to measure volatile PFAS, they have to wear it 7 days or we're not going to be able to detect it. You wear it 1 day, you're not going to see it, but there is exposure that's ongoing. And I just think because it integrates exposure over time. And if your question is what's the average exposure, I think 5 or 7 days is going to be better than 1 day. And you're going to have more signal and you're going to be able to measure that a little bit better. So that's just my perspective and just something to keep in mind.
Thanks, Heather. And I should note that ideally, we would want to collect a urine sample every day for a week, for a year, if we had unlimited resources and participants had unlimited time. So, for a lot of our studies, they do end up being more cross-sectional. And so just thinking about if we can only collect one urine sample from a participant, wouldn't they only be able to wear the wristband for the 24 hours previously, because that would correlate with the levels that we're seeing in the urine? Or do you think that we could still have them wear the wristband 5 days prior to collecting that one urine sample at the end of that 5-day period?
But it sounds like maybe you're limiting yourself to what you're measuring in urine. And if you're doing that, and if you're sure of the half-life and the chemicals, then maybe that's okay. But not all chemicals have half-lives under 24 hours. Sometimes they're longer.
That's
Right.
true. I guess it depends on the approach we take. If it's a screening tool, then they could wear it for much longer. I mean, ideally, perhaps they'd wear 2 wristbands, one for 1 week and then one for 1 day. And the 1 day one would correlate with the urine, and the others would be used more as a screening tool to identify other chemicals you may have missed.
Or you might need to measure wristbands like 3 days and then collect the urine samples right before it, because the urine may be picking up chemicals or the exposure occurred in the few days previous to where you collected that urine sample.
Yeah.
I see Kim has her hand up. We'll let Kim speak.
Yeah, no, I agree. I mean, I guess it comes down to what's the important question. If the important question is to really get the strongest correlation between a short half-life metabolite and the wristband, then you'd want them to match up if you really believe it's a half-day, half-life. I think you limit yourself for the reasons that Heather said and I had said earlier, that by doing short wear times, you are limiting that you're not going to pick up as many chemicals. And if you're trying to understand the breadth of exposure to identify new chemicals of exposures, understand that, that bigger picture, you're limiting yourself. But again, if that's the most important question, then you would try to design the study to match as much as the information as you have. But if you want to take advantage, there's some other things that could happen there, as far as taking advantage of the wristband technology, as far as additional chemicals, all the things we've talked about.
All right. I'm gonna call on myself. This is Laura Cushing from UCLA. Yeah, I think to me, the beauty of the wristbands is really not to try to replicate what we're doing with biomonitoring, but to perhaps elucidate novel compounds, co-exposures, more of the exposome type idea in a surveillance project. So I could see, and I don't know how this lines up or is feasible with our restriction to designated chemicals, but if these could somehow be used to perhaps identify populations or identify chemicals that have not been a focus but need to be a focus due to their ubiquity in the California population, I think that would be really amazing. Sorry, I lost track of hands. Oh, Rika, why don't you go ahead?
Yeah, I mean, one thing, you were talking about populations and occupational groups. So obviously occupational is near and dear to my heart. One of the things that I was thinking about is it seems like these wristbands would be great for monitoring, people who, say, farm workers who are it's not going to be very easy to, get blood samples and, do multiple samples or, sample over time. And you could do that, having someone wear a wristband is not asking, a lot of them, they don't have to do the types of things that they often, you might have to do for, if you have to come in for blood sampling or urine or whatever. And then also I was thinking, when we were talking about the biosphere and those, it would be really interesting to compare farmer, people who are actually working in the fields versus the families and, you could assess, maybe exposure to pesticide drift and things like that so I just think that this would be a really great tool for different populations. And that's just one that came to mind.
Jenny?
I was gonna basically say what you said, Laura. It's a comment, but just to build on what people have said before, I think the purpose is important. So if it's sources, I think the firefighter study was really interesting because it had a wristband when they were doing one activity, going to a fire, and then a wristband when they weren't, and it allowed them to look at those exposures separately. So that would be one way to do it, to actually have different, wristbands being worn or taken off and put back on or whatever, kind of for understanding sources in the understanding dangerous occupational activities, for example. But also, like Kim said, if the behavior is stable, it doesn't matter if it's a short half-life, because it will correlate well with a 7-day exposure. So for example, cotinine, again, a metabolite of nicotine, is only 17-hour half-life, but it's extremely stable in people. Very, very stable, because the exposures to secondhand smoke or whatever tend to be very reproducible, but not always. There's kids that see grandma once a week, or so there's value of looking at 7 days, like Heather said as well. But I think that, getting back to what you said, how does this add value to what we already do? I think it's important, because when I first read the last bullet point, I was thinking in terms of kind of validating, in a sense, the wristband versus the year. And I think maybe that's why you wanted the thing, but maybe we don't want to do that. We want to have another reason for doing it, I guess.
Thank you for those comments. Oliver?
Yes, so I would like to say one thing that I think is not quite clear yet, and that is the cost and the opportunity here. So one thing that you do when you have blood or urine taken is that you have significant cost in collecting the samples. You have to have phlebotomists, for example. You need to reach the people, or people have to drive someplace. And with the wristbands, I think it is much easier to do a much larger scale study, where it's much less costly to do, a study on 1,000 people, for example. And with that, you get a lot more statistical significance. So I think we should not try to mimic or directly replicate what you find in urine or plasma, but rather saying, we want to know what people are exposed to. We want to know the different populations in California, and that gives us an opportunity to do so. And in the sense of what to report and how to report back to participants, that's an interesting question. But at least we can say, look, we have large suspect screening lists. These are the ones that we usually don't report on, because we usually go for something in plasma or urine, which is very hard to detect, very low abundant, and we don't often see it. So that's why we need very dedicated methods, because of the turnover in the body. But with wristbands, we can accumulate, and we don't have the problem of enzymatic degradation like we have in humans. So we have opportunities to do much larger scales across California in different populations, including in vulnerable populations like children. So I think we have a lot of win-win-win situations here. And I would highly recommend trying this route for specific questions.
Thank you, Oliver. I do want to mention, though, a reminder to the panel too, though, that we are a biomonitoring program, so I think we still have to include biomonitoring regardless in all of our studies. And so then it's how can we add on the wristbands to complement those studies? And maybe it is that we should think of it more as simply a screening tool. And so we don't have to think so hard of how to correlate it with the measurements that we're seeing in our biomatrices. I think that's what I'm getting from this conversation.
Kim and then Tom. Oh,
I'm
sorry. Okay, let's do Tom and then Kim.
I mean, your statement that it has to be biomonitoring to use it, I think it's important to recognize that we have used non-biomonitoring types of studies to designate chemicals, right? So it is, I mean, given our precedents, we did like for siloxanes, I think as a class, we didn't look at biomonitoring to decide to list it as something we wanted to biomonitor. We looked at the growing use of the chemical and the fact that it was showing up in different samples, not biomonitoring samples, to say we should biomonitor it. I mean, it's kind of like chicken egg in a way, but I mean, if we did a wristband study that found chemicals that we hadn't thought of before showing up all over the place, that would enter into our process for designating, which we haven't really used a lot lately, but early on, that's all we did all the time, was we were building up our list. So we were doing a lot of studies where we did not use biomonitoring to decide to biomonitor.
That's a great point. Thanks, Tom. And that is also what we were thinking of using the wristbands for potentially as well. And that's where the question came from, if we should use semi-targeted or non-targeted analyses. And it sounds like maybe we should use a more non-targeted analysis to identify chemicals that we might want to add to our designated list.
Kim, did you still have a comment?
I think I forgot my first comment, but as far as I can't remember, it'll come back to me. Yeah, I guess I kind of doubled down on the idea of what is biological monitoring. This is measuring a biological exposure. So I guess it depends. It's a fine line, right? And how you define biological monitoring, I think you are measuring a biological exposure, which is the intent. But it's also the ability to explore, which I think Tom maybe just said, explore new chemicals, right? I mean, the idea is to understand that exposome, that whole, which is more complicated than just chemical exposures, but, you know, just living in some really finite space with, you know, a blood or a urine sample is really putting your blinders on to a whole lot of exposures of chemicals that might actually be more important. You put this page up. Thank you for putting this page up because I couldn't remember all of your questions. We've been reporting back to the community for a decade now. First of all, they love wristband results. They're not overwhelmed with the fact that this is new technology or that there isn't a clinical level that says, oh, this means you have high cholesterol or this means your cholesterol is okay. They really do with proper, you know, report back, understand the idea that this is a new technology, and they like, what they do like is that they want to see everybody else relative to themselves. So we do tend to always include, this is you, and this was everyone else that we did. And that is incredibly satisfying for folks. They understand, oh, I'm high. Like, what are some, like, I'm high. And then we can talk to them about, do you burn incense? Do you have a natural gas stove? Do you have candles? You know, in the case of pHs, you know, or I'm low compared to everybody else. It really is a very important, engaging conversation. And it doesn't have to be about a clinical level defined that you have cholesterol above this level of cholesterol below. So I get that it's not required to report back, but I find that the participants really enjoy it and they get over what I think we are paralysis by analysis scientists, that we don't have all of these questions answered. They don't even think about all these questions. They're like really wanting to know, like, hey, these are chemicals I didn't even know I was exposed to. Where do they come from? How might I change or how might I not change? So I find that it's been very rewarding to report back results, and you know, I would strongly encourage it.
Thank you, Kim. I'll just mention that we have a similar approach to our biomonitoring results return packets, where we share participant results to others, or compare participant results to others in the study. And it's nice to hear that you've had positive feedback in doing something similar for the wristbands.
I saw Martha had a comment and then Amy.
Sure, Martha, Sandy, Ilya. Maybe just the terminology, the wristbands are really a nice way to figure out what people are coming in contact with. So it's better than a stationary air monitor, which is, an improvement on that is something in measuring air in your house and just outside your house. An improvement on that is putting a personal air monitor on your lapel and walking around all day, or a backpack. The wristband is capturing more, but measuring a chemical in the body, in the urine or the nails or the hair or the breast milk or the blood, is biomonitoring. So we do have these different terms that we have to deal with. And we are thinking of how do we use wristbands to identify, as you've all discussed, other chemicals we should be considering measuring in our biological fluids, and maybe adding to the designated list if we need to, because we're seeing that people are exposed because it's on the wristband. So perhaps our terminology, the way the program is using the term targeted versus non-targeted or semi-targeted, is confusing to the analytical chemists. Because our wristbands, we did a small pilot study that you'll hear more about. You've heard a little bit about, you'll hear more about at another meeting. There was a set, it was targeted for many different chemicals, but they didn't necessarily correlate with the chemicals we were measuring in those people in the biomonitoring study we were doing. So I think maybe our use of the term semi-targeted or non-targeted we were misusing the term when analytical chemists say that. So I just wanted to clear the air on that. That's all. Thank you.
Thanks, Martha. Amy?
Amy Padula. I guess I just had a quick comment in concert with, I think, what most everyone else is saying, that I agree that having a longer term sample with the wristbands would be a really kind of illuminating, to be able to kind of a broad scope. And I think also is just to get away from the idea that this kind of urine sample is our gold standard, is, I think, a kind of misconception that we maybe are holding on to. I mean, I think, of course, we naturally compare. It seems every study we've read shows the comparison, but if we're going to move forward, I think this seems like a logical direction. I also wanted to bring back what I think both Kim and Heather mentioned, that the day of the week really matters. And so then the one day really kind of is problematic in that sense. The one question I had about the report back, I agree that showing people's value in relation to everyone else especially in a graphical form, is a really excellent way to convey that information, especially when we don't have levels or standards that are considered high and low. I was curious, given the number of chemicals that are usually measured in the wristbands, I was wondering how you decide how many, which ones. I know you've mentioned hundreds or even thousands of chemicals. This is something we're trying to sort out, and I was just curious how to deal with the volume of chemicals for the report back. And that was directed towards Kim, if you don't mind.
Yeah, so we usually have a one-pager that summarizes the study, and then we have an individual report that gets generated for each individual. So the summary, oftentimes I'll pick out 2 or 3, usually like 3, I don't know why, 3 chemicals where I feature just what those chemicals were, where their typical sources are, and the individual report that the person gets, which just gets generated on the backside of that. It's actually not that hard if you have great laboratory information system. So we generate a plot for all of them. It's like where you are versus where the rest of the group was. So we actually do include that, but a lot of times we feature, for instance, a pH, we do a lot of those. And we feature like if you were, and so you can go back and look at your data, your individual data, and you can see how you are sort of in the spill of data. And then on the one pager, there'll be featured ways in which you could reduce your exposure. But they actually get like a one pager with some interventions, and then they get their individual report. And the individual report shows everything for them relative to the group. So each one has a little dot, and here's the rest of the group. I can connect you with Diana Rollman. She makes all these for us, if you're interested, and she can send you some examples of we've used. That's when we use the really big method. Like if we were just doing pHs, that's sort of different, or if we were just doing phthalates or something, that's, it's smaller. It doesn't take that much to do. It's kind of push a button at this point for us because we haven't already coded.
Thank you.
We do have a couple of online.
Great. Let's move to the online comments and questions.
Shanwen, did you want to unmute?
Hi, here's Jian Wen again. Thanks, Kim and Heather, for excellent talk. And then also thanks everyone for discussion. I learned from this talk, I also think, what's the biomonitoring program's purpose? We look for the source, we look at the time trend. Does the wristband help to address these questions? We look at the environmental component monitoring, air, water, soil. Does that help to address questions? Regardless which compartment we monitor, we can't share the common objectives. So we should not look at this approach separately. We need to integrate them together. So what I see, at least like many people already talked, this complementary advantage provided by wristband, biological sample don't have. We have a time delay, and for collect the blood and urine, we cannot do large scale studies. And the wristband maybe provide pre-warning systems. Also can monitor the trend, monitor the interventions and effectiveness. I think the programs needed to consider from the objective of the biomonitoring and the environmental monitoring and the active sampling, passive sample, that we all address the same, try to go to the same place. So I like to thank the presenter and for also suggest a program to comprehensive overlook this is possible be a valuable tools. Thank you.
And thank you, Shanwen. We do have one question from Beth. She said, I noticed the bands are labeled with embossed and colored ink lettering. Do those chemicals need to be considered that are used for the coloring of the wristbands? That might be a question for Kim or Heather.
So we don't usually put paint on, we don't usually paint the wristbands. We have different colors, and then we just press the study, whatever we're going to put in the study line. So we don't put paint. We went through this with about 20 plus colors where we tested. So we have this whole process for testing background after we're done processing them, elasticity, right? There's all these good manufacturing practices that every batch gets tested, and every batch gets samples actually put into archive in case anything comes up from that batch that we've produced. And after about 20 chemicals, we stopped. However, it's one of those you can't prove the negative. So I finally, everyone wants their own special color. I don't actually let people choose anything beyond the 20 I've already tested, because I'm kind of tired of doing all that. It's a lot of work to test every color in every situation, because there's a QC question in here too that Heather or I can answer. So we did test all of those, but I admit I don't add any more colors to my set colors that I offer people.
Yeah, and I just wanted to add on to that we're always analyzing field blanks anyway. And so field blanks, if there is something in the coloring or a dye that doesn't come out during the cleaning process, most of those come out in the cleaning process, that some of them, that they remain, they're accounted for in the field blanks. So we've never had a problem with it. We, like Kim, only use a handful of colors. I will say though, because I found this interesting, we did have a group that really wanted to use yellow wristbands. And when we cleaned them and analyzed them, we found PCB 11, which I think was in the yellow dye in there. Now it was really low level and we can account for it in field blank, but it was just interesting that it popped up and we saw that. So it's something to be aware of, but we always account for that with field blanks and checking them with the cleaning process.
Yeah, we don't use yellow either. Concerning the QC question, so as I mentioned, about 30 to 50% of our samples are QC. We usually do triplicates in the field. We do trip blanks, field blanks. Those are two different kinds of blanks. We do extraction blanks. We also have from every batch that we make, we include one of those. We have prep blanks. We have on instrument blanks and CCV. So we do a CCV, continuing calibration verification, every 8 to 10 samples. And so all of those are sprinkled all through there, somewhat to my chagrin, because the staff are analytical chemists with a big ANAL part, as in, and it's very costly. But I'm always saying we don't need to run that much QC. We know these. We can run fewer blanks. But I get this. It's a safety blanket for them. They're Linus. They want to hold their blanket. What else was in here? I think that's it. And all that information also gets included, if you want, in a report. Yeah.
Thank you. Are there any more questions online? Rebecca or Stephanie? No, okay. I had one. Okay. I wanted to follow up on the report back. I'm curious, so I think Heather, you mentioned earlier that you normalize sometimes by the amount of time somebody wore the wristband if there were slight variations. So is that kind of standard since Kim, you emphasize that people really like to see where they stand relative to others. If people, took it off a day or two later than instructed, how do you handle that in the report back? So that's one question. And then the second question was, and forgive my ignorance here, but I'm guessing the units on the results are like, micrograms per gram of silicone or something like that. So for analytes where we do know certain concentrations are hazardous in air or in the body, I know this is a little bit different. It's not biomonitoring, it's not internal dose, it's not ambient air, but can you speak a little bit to how, for example, we have, a practice, if we see really high levels of something in somebody, you want to follow up with them and let them know. So are there kind of levels you've established where you would become concerned that someone's extremely exposed and needs to be followed up with, or can in some way compare sort of the units of measurement that you end up with to regulatory or health-based benchmarks?
Well, I'll go first and then turn it over to Kim. I know there was a lot of questions in there, so I hope I can remember them all. When we first started reporting on wristbands in our lab, we were reporting on nanograms of chemical per gram of wristband. after we did that study, the Salmon et al. 2024 study, where we looked at accumulation over time and just saw that there was a strong, almost linear dependence, we have now moved to doing nanograms per gram per day in all of our statistical analyses and how we report them. You know, previously we made sure there wasn't a lot of variance in the deployment period, right? So if it wasn't more than 20%, we usually let it go and left it nanogram per gram. Now I become more convinced, at least for the chemicals we monitor, because I think they are in the linear phase and there's some variability depending on deployment time. We do a nanogram per gram per day, and that's how we report them and share them. But like Kim, I do think it's important for the report back. You know, we have some studies where we report back blood PFAS levels, and then we have some with wristbands. But both of them, you know, they look for that strip chart, right? That strip chart is comparing them to everybody else. And that's exactly what they hone in on. And they want to know, are they at the top, the bottom, or the middle of the pack? So I completely agree with what Kim said. I think it's valuable, and that's really what they want to know. Not, you know, even with PFAS, I don't think they care as much. Am I over the NASEM clinical guidelines of 20 nanograms per mil? They want to know if they're in the middle or in the high ends. So I do think there is some value to report back there, keeping it on that basis. But I do use nanograms per gram per day. I'm probably forgetting the rest of your questions. If you want to remind me, or we can have Kim comment as well.
I think you pretty much hit on it. So you normalize by the amount of time they wore it. That was my first
We
question.
do.
And then the second one was if you have any strategies for kind of comparing your units to regulatory or health-based benchmarks for at least some chemicals and or like flagging particular individuals who are off the charts that you think need to be followed up with because there's actually like an acute health risk.
Sure. We don't actually put them into the framework right now. I don't think we've had the case where we measured some exposure that was really, really high that we were worried about. You know, sometimes like in the firefighters, we'll see really high exposures to some of the, in one case, we saw really high exposure to some of the flame retardants, but there's nothing they can do about that. And I don't want to alarm them because they've already been banned and some of those exposures are probably coming from legacy products. And we don't really have a threshold in blood, right? So we haven't been confronted with that yet. And I think that's something that needs some attention if they're going to be put into that framework moving forward, for sure. I don't know if Kim, if you have additional thoughts on that.
So we usually give the results in like nanograms per gram wristband, because our screens do flirt with both ends of those equilibrium and curvilinear areas. So we're oftentimes really broad chemicals. We do have, Stephen O'Connell put a paper out where we have a pretty good idea where the break is between dermal and air, based on some ChemFes properties and some other things that we've done with controlled exposure studies in exposure boxes. And so we have a pretty good idea, is it a inhalation or is it dermal? And where we're going is we're adding performance reference compounds. Those are essentially internal surrogates. And so it gets at things like, do you run all day or do you sit all day? Or are you in a sauna all day or are you in the Antarctic all day? So the performance reference compounds essentially benchmark you into where you are, because those dissipation rates for a few of those could be then modeled into the rest of the compounds. And that's done with all the other kinds of, many of the other kinds of passive samplers. So we're working on that. But right now we're giving like nanograms per gram wristband to our clients. Most of our, I think almost all of our chemicals don't really have like a level. That's part of the story, is that we're the chemicals that we're finding that are 93% of the wristbands actually don't have a level. And so that's why the story becomes, how are you relative to everyone else? What are the sources of these chemicals? And so we really haven't gone into that space yet.
We can share.
Yeah, Amy.
One question I had for Heather, this is Amy Padula. I was impressed with how many chemicals are able to be analyzed and also how you kind of cut the wristband up to be able to do it all. I was wondering, for the biomonitoring program, whether there were certain classes of chemicals that you would prioritize over others based on your experience of analyzing so many different ones. I guess, with other studies, there seems to be a lot on pesticides, but it seems like other ones haven't been done as much. So I was wondering if you had any thoughts on that.
Yeah, sure. I guess based on our experience, I know pesticides come up a lot. I just think we have to be careful with pesticides because some of them are exposures all diet, and so we don't pick up a lot of them, but there are some pesticides that are used in building materials. So azoxystrobin, for example, is a fungicide that's applied to drywall. We pick that up actually more commonly than I would expect, which I think is coming from an indoor source. But then you look at pyraclostrobin, and that one's really more food and not in building materials, and we hardly ever pick that one up. So I think we just have to keep in mind what we look for. Again, you're focusing on those exposure routes that are more inhalation, dermal, indoors. And so you're going to miss things that are coming from diet. I do think pesticides are of interest. There's a lot of new use pesticides out there, but there's so many of them. Ones that I think are really interesting are some of these volatile PFAS that we're seeing in indoor environments that haven't been well studied. There's also, we're seeing a lot of, I think I showed it in one of those plots, 4-ter-octophenol and nonylphenol, which I know there's a lot of attention on those back when I was a PhD student, but it kind of fallen off the radar. We see very high levels of nonylphenol in almost every single wristband we measure. And I am wondering if that's coming from breakdown of an antioxidant that has a nonylphenol substructure in it as used in some plastics. I'm not quite sure. We typically think about that being coming from like detergents, but we have phased those out of detergents a long time ago. So I don't think they're coming from detergents. I think there's probably another source. But plastic additives in particular, I think, are a big class of compounds that need a lot more attention. And we pick up quite a bit of those, whether that's a flame retardant additive or an antioxidant, dyes, stabilizers, vulcanization agents. There's a whole slew of these that I think have been understudied that need a lot more attention as well. So those are the few. And I'm kind of biased to the flame retardants. I think there's still some interesting things to focus on for some of the flame retardants. Particularly, we focused a lot on uses in furniture, but there's so many used in the electronics sector that we don't know about. And so I think, more attention on those would be helpful as well. So those are just some of my initial thoughts.
Hi, Jenny Quintana. I had a very practical question. You showed that very nice Mylar bag and little tin, Heather, for mailing to people. How do you instruct participants to prepare a field blank? Do you tell them, like, open the tin and touch it and pick it out and put it back in and mail them separately? Or, we've had a few participant-related mix-ups where everyone does it apparently well, and then suddenly one of the exposed ones is very low and the field blank is really high. I'm just curious how you do field blanks for those mailed in participant studies.
So in many of our studies, we're doing consenting in these community settings or a specific site, and that's where we hand out the kits. And so we bring field blanks with us to those sites in the same packaging and in the same materials. And then once we hand it to our participant, we give it to a participant with a self-addressed stamped envelope to mail it back to us, maybe the following week. So in those cases, we're just taking field blanks with us to those community events. Usually we try to open and close them and put them back in the tins, and then we bring them back to the lab, and that serves as our field blank. We do not send a second wristband with all the participants, although that's something we've talked about. But I will say in my experience, we haven't come across big issues with field blanks compared to what we measure on the wristbands. You know, we certainly monitor them, we blank correct, we estimate our detection limits based on the field blanks. We do run laboratory processing blanks as well. But they haven't really been an issue for us, at least for the chemicals that we monitor in our targeted panel. So that's, you know, that's typically how we've been handling it. I'm sure there are better ways to do it. And we do have a lot of collaborations with other groups across the country. And so sometimes they do things a little bit differently than what we do, but so far it hasn't been an issue.
Thank you.
Sorry, you said there were a couple online, or these two that I see before me. Okay, great, Melissa. Okay, Kathleen.
Kathleen Adfield, back to the results return type of questions. So we have the situation where we're picking up both the concentration in the air and perhaps the dermal deposition, but also the absorptive capacity of the wristbands, of course, which is going to be different for all your different chemicals. So I'm just thinking, like, not only do participants look at where they are for each one, and that kind of normalizes it, right? But we've also talked to our other biomonitoring colleagues in other states, and they say people also look, okay, which one's that has the highest numbers? And so then you have sort of two things feeding into what makes the highest numbers. So wondering if you've had to communicate on that aspect at all to participants.
We really have not had a lot of people ask about the numbers. They barely look at the axes. They just look at where they are relative to the axes. Again, there aren't regulatory levels even in air for most of the chemicals that we're looking at. Like if we look at a host of alkylated pHs, which are very abundant. Other types of chemicals, fragrances, a lot of personal care products, etc. There aren't regulatory limits, so the numbers don't really mean that much. If the numbers, if you feel like they're going to be distracted by the numbers, really don't have to put the numbers on there. If you felt it was a distraction, right? It's just really to communicate that you're in the pack or you're high relative to the pack, and these might be the sources that you might consider reducing in your life to reduce your exposure.
This has been great. Thank you so much for everything you've presented. I think we have a lot to think about for the program in terms of, what is and isn't biomonitoring and how do we deal with our designated list. But one of the real logistics for us is the cost of adding new panels, the methods that we have, and the time it takes to turn around results to our participants, because we try to get things back to people within a year. Can you talk a little bit about that in terms of how you work with other collaborators, about the costs and how they compare with some of the more traditional methods that we see?
Right. So for us, we usually cut the wristband in half, archive half, and extract half. And the reason I extract half is because my PAH's method, my alkylated method, my flame retardant method, my phthalate method, my pesticide method, my OPH method, chlorinated paraffin method, my massive method, they all come off that 1 ml extract. So I just aliquot out and go to all those different instruments. As there's a cost savings, I only have to extract the wristband once. So they go to all those. So if you do more than one method, you get a discount because I'm only extracting it once. The purge and trap would be different because that has its own, that then consumes the wristband for the purge and trap method, just like it would for a water sample or otherwise. Typically, we like to get samples out within 30 to 60 days. We had 450 samples here. We had them here for like 10 days. But those are because they're using methods that are turn the crank kind of methods for me. It would be different if there was a method development or something, but you're talking about probably doing one of our methods that are off the shelf. Other commercial laboratories, I think, would be under 30 days typically, not Antonio's at CDC. She's much longer. Love her, but she's long. But for us, it's usually 30 to 60 days.
Sure. My situation is probably a little more complicated. My lab is part of the NIH Human Health Environmental Analysis Resource, or HERE, which is going to be sunset, but it's still running right now. And because of that, I have to set my lab up as I can't do fee for service. So we have to write subcontracts and be part of funded studies to support any analyses in my lab, because the lawyers consider it an audit risk. So when I collaborate with folks, it's usually through some kind of subcontract on an NIH grant. And we kind of give them a budget based on the number of samples and what kind of panels they are interested in. And so the numbers I'm about to give are for direct costs, because then Duke adds on the indirect costs on top of that as well. So we start with our basic panel. That's just the extraction on the electron impact mode, which does that targeted panel that I talked about for BFRs and PAHs and phthalates and pesticides and things. We charge $250 a sample for that one. If you add on the injection into the NCI instrument for the brominated flame retardant stacks and furans, it's an extra $50 per sample. If we add on the volatile PFAS, it's another $50 a sample. And then if we do both targeted and non-targeted on those samples, then it's $500 a sample. So that's our current rates. We'll likely have to adjust those. But like Antonia, we have a large queue because we are supporting analyses for all these other programs and consortiums right now, that we actually have a queue of samples to run that will take us through at least next summer right now before we can do anything else. Now, we do provide wristbands to a number of collaborators because, you know, we ask them to buy the wristbands and then ship them to our lab, and we just clean them and put them in the Mylar bags and tins and then return them to them for use in their studies. And if it's a small number of samples, less than 100, we usually do it at no cost. If it ends up being hundreds to thousands, then we set up a subcontract and they help buy some supplies for that. But the cost of the kits that we prepare are under $5 a kit. They're not that expensive. When you account for the labor, and the raw materials are very small. It's the labor and just packaging them that takes time.
Thank you so much, Heather and Kim. This is, I personally have learned a lot, and I think this has been a very valuable conversation for the Biomonitoring California. We're going to have to move to our open public comment period. If there are no open public comments, we might have a few minutes for another question or two, but let me pause here and announce that we do have time allotted here at the end for open public comment, during which commenters can provide comment on any topic related to Biomonitoring California. Webinar attendees can submit written comments and questions via the Q&A function of Zoom or by email to biomonitoring@oeha.ca.gov, and we'll read them out loud. Or if you wish to speak, you can use the raise hand function and Rebecca will call on you. And if you're attending in person and wish to comment, please come ahead, come to the front or raise your hand so that I can call on you. Rebecca, do we have anyone online wishing to comment?
No, not at this time.
Melissa?
So just to move us away from the wristbands for a minute, I want to make sure we had time if we spoke about speciated arsenic and phenols this morning, and we're looking for input if you have ideas for any additional analyses we should be doing, or partners who might be interested in working with us on particular subject matter experts whom we could talk to about either arsenic or phenols. So just wanted to remind you that that's an outstanding question. If you have thoughts, we could either bring the conversation there or reach out to us as a program later. I know there are probably lots of other questions about wristbands.
Any thoughts on that question about arsenic and phenols? I mean, I will just off the top of my head say, I haven't given it much thought, but, similar to the work that was done looking at PFAS in drinking water, seems like that would be worthwhile to do something similar with the arsenic, especially if you have some geographic variation in where your Care 2 participants are. There's 200 water systems in LA County, so there is quite a bit of variation in arsenic. It might tell you something about the source. Is there anyone else in the public wishing to speak online or in person?
No, we haven't received a request from the public.
Okay, so I guess we can just open back, sorry. Okay, so we have 5 more minutes. We can return again to the question of wristbands or this question about arsenic phenols or anything else, if anyone has remaining thoughts or comments to share. Okay, well, then we will go ahead and wrap up and adjourn. Thank you, everyone, for participation and to the staff for their fantastic presentations and to our guest speakers for everything you've shared. Now, a transcript of this meeting will be posted on the Biomonitoring California website when it is available and the meeting's adjourned. Thanks.